This is lesson 3-5, scatter plots and lines of fit. So I'm on page 128. Okay, so describe the type of association each scatter plot shows. So you always read your graphs from left to right. So it starts low and it's going up. So this is trending upwards, so it's a positive association. I really could not draw a line anywhere through this that would really show any kind of relationship. Everything is all over the place. So this is no association. All right, now we're looking at a graph here. And just from looking at this graph, you can tell that we've got hours after sunset and we've got 12 hours here. And we have the temperature in degrees Fahrenheit. And it's starting at 72. And it's a little squiggly, but it's going down below 60. Maybe this is 55. Let me see, 60, 62, 64. So this is 58. The little breakdown here just says that there's a lot of numbers between where they're ending the graph and where 0 is. So if you have a hard time reading graphs, or if you just want to make sure you're being precise, sometimes I like to go in and fill in those other numbers. It makes it a little easier to read. There's 1, 3, 5, 7, 9, 11. So after 10.5 hours, it got down to 58 degrees from 72. So how can the relationship between the hours after sunset and the temperature Y be modeled? So X is hours after sunset, Y is the temperature. If the relationship is modeled with a linear function, describe the correlation between the data sets. So you can write an equation for this, which we're going to do in the next part. But as it gets more hours after sunset, that just doesn't sound right. I'm trying to think of the right way to say it. The more hours it's been since sunset, the more the temperature has dropped. Or the more time since sunset. And obviously there's a direct correlation there because, you know, the sun is what makes things warm. So that's an easy one to see. Sometimes it's a little hard to be sure that they definitely have a causation, but we'll get into that later. Correlation versus causation. What trend line in slope-intercept form models the data from example 2? And then we're also going to answer this question after that. So let's look back at this. And remember, you can just use the edge of a piece of paper, an index card. It's starting. We don't want to just go off of this point. We want to go as close as we can between all the dots. So I'm trying to figure out how I'm going to put my phone where you guys can see this. It's just about impossible. My guitar stand's too short. Okay, well, I'm going to do the best I can here. So we want a line that goes through all of these points, and it should come as close to all of them as possible. So I think that looks pretty good. It's really nice if you have like a clear ruler to do these. I don't happen to even have a ruler at home. I kind of like to do things using just random objects so you guys can see how you would do it. Yeah, I think that actually looks pretty good. It should come down a little bit right there. All right, so it does start right around 72 degrees. Maybe it's right between 70 and 72. So you could say your y-intercept is right around 71 degrees. We're going to write it in slope-intercept form. So we have y equals, we're going to put our slope right there, and then x plus 71. All right, I'm not going to start here because I'm estimating that it's 71. Remember, you want to go to where your line is crossing as close to a corner as you can. Follow it down. It's not crossing here or there. Right there is pretty close. Yeah, I think that's the closest it's going to get. It's right there. So we're going to go and draw a slope triangle that goes between those 2 points. And I think I saw another one down here. 2. Yep, perfect. Right there. So I think that's a good slope. Down 2 over 3. Yeah, it follows it pretty well. So the slope is -2 over 3, x plus 71. So what that says is it goes down 2/3 of a degree every hour after sunset. So it starts around 71 and it drops 2/3 of a degree every hour. All right, the last question here, this is a really good one. Explain why there could be no data points on a trend line, yet the line models the data. So, like, I have a pretty good line here. I think that if I tried to plug in any hour, I'd get pretty close, except for, 7 and 8 here. And even there, I'm only off by a couple degrees. So just because it doesn't hit the data points, maybe it's like this. And I've seen graphs like this plenty of times. You want to get as close to the average of those points. You're not trying to hit all the points. We're not trying to zigzag and connect the dots like I see you guys playing on your paper. We're trying to get as close to each point, so each one is about the same distance from my line. So, the line should be close to all points, not just touching more points. I don't know how to word that exactly. Like, just because, like, if I put it right on these 3 points right here, okay, I would be touching more of them, but I'd be way away from these other points, and that line wouldn't be good. It wouldn't give you a good average of what those data points are.